Hey guys, today we're going to talk about inscribed angles. So our goal for today is to find the measures of inscribed angles. So the first thing you probably want to know is what is an inscribed angle. So it says an inscribed angle is an angle that has a vertex that's on the circle. Okay, so if I look at this diagram right here, let me see if I can make it just a little bit smaller. Okay, that angle R is the inscribed angle QRS. The vertex is on the circle. Okay. We also need to know the vocab term intercepted arc, and it says intercepted arc is an arc that has endpoints on the sides of an inscribed angle, and it lies on the interior of the angle. So basically what this is saying is that I have an angle that's going to open up to part of the circle. This part of the circle that's inside of the angle is the intercepted arc. We would call this arc QS. So QS is the intercepted arc. Okay, off to the side it has some vocab, and it says, what is the inscribed angle? We would name it angle QRS, or we could just call it angle R since it's the only angle on the diagram. What is the intercepted arc? It would be arc QS, and when we label that arc, we put that arc over the top, so it's kind of rounded over the top, indicating that it's an edge of the circle. Okay, so it says, what is the relationship between the inscribed angle and the intercepted arc? What I want you to know is that the inscribed angle is half of the intercepted arc. So the angle is half of the arc. It says, using this circle, draw an inscribed angle and name it angle MOD. So if I kind of just drew in this angle right here, MOD, it's inscribed because the vertex is on the circle. Then it says, draw a central angle intercepting arc MD. So my central angle would start at the center and go out to the edge. It says, state the relationship. On circle A, the measure of angle MOD is, so this angle right here is what it's asking for. It opens up to which arc? It's intercepting this arc MD. So I would say it's half of the measure of arc MD. Or it says, what if I wanted to find this arc MD? Well, it would really be 2 times the measure of angle MOD. Let's work on some examples so it makes a little bit more sense. Okay, so here it says find each measure. So the first thing it asks for is the measure of arc XY. They want this arc right here. Well, the relationship, this angle Z is half of the arc. So if I want to get back to the arc, I need to take this angle and multiply by 2. So this arc measures 46. Okay, next one asks me to find the measure of angle E. So this angle right here, what I'm going to do is I'm going to take the arc and divide by 2, and that's going to give me 81 degrees. Okay, next one says, what's the measure of arc QS? Well, how many degrees in a full circle? Think like a whole rotation. 360 degrees. What do I already have on this circle? Well, I have 120. I also have 140. So if I subtract those, I'm left over with 100 degrees. That 100 degrees is going to be arc QS. And then it says, how do I find angle R? Well, angle R opens up to that arc, so it's going to be half of that arc. So if I take 100 divided by 2, I end up with 50 degrees for that arc. Okay, next one says find the measure of arc MN. So starting at this angle, it opens up to MN. To go from the angle to the arc, I multiply, so this would be 62. Then it says find the measure of arc MP. Well, MP is this arc right here. This line right here cuts through the middle of the circle, meaning that from P all the way over to N is half of the circle. Half of a circle is 180 degrees. So if I take 180 and I subtract 62, what am I left with? 118 degrees for this arc right here. Okay. Now we have some theorems that deal with inscribed angles. It says if 2 inscribed angles of a circle intercept the same arc, what could we conclude about those angles? Okay, so what it's saying here is angle C is opening up to this arc DA. Angle B is also opening up to that same arc. They both intercept this arc right here. what could we conclude about these angles? Well, what if I put a measure here for you? What if I told you that this arc measured 100? What would be the measure of angle C? Well, I take the arc and divide by 2 and I get 50 here. What would be the measure of angle B? Angle B also opens up to the 100, so that angle would have to be 50. So we're going to say if they open up to the same arc, the angles have to be congruent to each other. So angles that open to the same arc are congruent. Okay. Next one, it says, think about it. If an inscribed angle intercepts a diameter or a semicircle, what would be the measure of the inscribed angle? Okay, so diameter of the circle stretches all the way across. What it's saying is, what happens if this angle intercepts the diameter? Well, what is half of my circle? What's the measure of half a circle? Well, if I take 360 and divide by 2, that means half of the circle is 180 degrees. This arc right here is 180. Now, if this angle opens up to 180, what will be the measure of this angle? 180 divided by 2 gives me 90. So this angle will be 90 degrees. Okay? It says, what would be the measure of the inscribed angle? Well, we just said it would be 90 degrees. The angle would technically be a right angle. So if it opens up to the diameter, or if it opens up to half of a circle, it has to be a right angle. Okay, last theorem that deals with inscribed angles, it says, if a quadrilateral is inscribed in a circle, then its opposite angles have to be supplementary. Okay, so what they're saying is this figure right here has 4 sides, and it's considered inscribed in the circle because each vertex of this figure lies on the circle. Okay, so what they're saying here is that the opposite angles are supplementary, meaning that they equal to 180 degrees. So what would that mean? That would mean that measure of angle A and the measure of angle C are supplementary. The measure of angle B and the measure of angle D are supplementary. Okay, and then we have an example problem. So they're asking me to find each measure. It says find angle R and angle S. What we said in the last example is that angle R and the angle opposite of it have to be supplementary. So I could write an equation like 3x plus 75 equals 180. To solve here, I would subtract the 75, and that's going to give me 3x equal to 105. And then if I take 105 and divide by 3, I end up with 35 degrees. Now, one thing to be careful of is that's my x value, but is x actually the measure of angle R? No. Angle R is 3 times x, so that's really going to be 105. Okay. Now on this one, I guess technically I could have just said 180 minus 75, and that would have given me angle R. But when I look at the next example and it asks me to find like the measure of W, how would I find W? Well, W, I would take this angle, the angle opposite of it is angle Y. Those two together have to be supplementary, so I would say x plus 18 plus 2x has to equal 180. Okay, and as I work through here, if I combine like terms, how many x's do I have? Well, x plus 2x is going to give me 3x plus 18 equal to 180. If I subtract the 18, I get 3x equal to 162 degrees. And if I take 162 and divide by 3, I ended up with x equal to 54. Now, one thing we have to be careful of is they ask for angle W. And angle W is actually x plus 18. So here I would have to say 54 plus 18. That would give me my angle W. So 54 plus 18 would give me 72 degrees. Okay. It also asks me in this problem to find the measure of x. So I would do the same thing here. X and the angle opposite have to be supplementary. So I say 3y minus 7 plus 3y plus 1 equals 180. Combining like terms, I get 6y minus 6 equal to 180. if I add the 6 over, I get 6y equal to 186. And when I divide by 6, I get y equal to 31. So then if they want me to find the measure of angle x is right here. So I take 3 times, what was my y value? 31 minus 7. So 3 times 31 is going to give me 93. 93 minus 7 is going to give me 86 degrees. Okay? All right, so for today, it says an inscribed angle is blank of the intercepted arc. It's going to measure half of the intercepted arc. Okay? Assignment for today is inscribed angles practice posted on Google Classroom. Bye, guys.